In this course, we'll learn about programming language concepts by building interpreters. For us, an interpreter is a program that corresponds to this purple box here. It takes as input code written for another programming language. Then the interpreter turns its cranks and outputs a result, which is the output of computing what the program says. Now, you're already familiar with lots of different interpreters. A desktop calculator is one kind of interpreter that takes as input arithmetic expressions and outputs numbers. Another kind of interpreter is the JavaScript interpreter that's sitting inside your web browser. And people can also be interpreters. If you give someone a recipe, that's input, and the person works as an interpreter to follow that recipe and then output something like a cake as the result. So again, for us, interpreters are programs. The input to those is also programs. And as we explore new concepts over the semester, we'll be building new interpreters. So first, we'll extend the source language on the left to describe the new concept, and then we'll be improving the interpreter to give the concept implementation. What's the semantics? So we have a language, which is the source code, the input to our interpreters. We need a name for that. So eeny, meeny, miny, mo, we've chosen the name Mo, and we'll use that throughout the semester, Mo, 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 even though really it's a family of related languages. Well, the other reason for using the name Mo is that past versions of the course called the language Curly. So we have a Three Stooges theme. Mo is the brother here to Curly. Now, the language we're going to use to implement these interpreters, or the purple boxes on the previous slide, that's called Shplait. And to give you some of the history, Shplait is a grandchild of the Racket programming language, which comes to us by way of Rhombus. And Racket in turn is a derivative of Scheme and then Lisp further back. So that's one historic thread. Another source of inspiration for Shplait is OCaml and the ML style of programming languages. So you'll find the look and feel of Shplait is very much OCaml, the syntax and especially the type checker. And the internals happen to come from the Racket world. Now, why use Racket? Well, first of all, your professors are programming language researchers, and Racket is the main tool that we use to get our work done. Racket is also a programming language that you can use for all sorts of things. And what sets it apart is that it's a language that has tools for creating other languages. So there's many examples for this in the Racket world, languages for typesetting, languages for writing type checkers, and there's Shplait, which is a language for implementing interpreters. Lastly, I need to explain the name, Shplait. So as you might expect from an ugly name like this, it's got a technical meaning. The SH stands for shrubbery, which is the notation system inside Shplait. This is what helps make it look like OCaml, even though it's implemented in Racket. PLAI is for the textbook that this course was originally derived from. And T at the end is for types, as we have in the ML family. So putting it all together, Shplait.